All right, welcome back to another video, and today we're working January 2021 paper 2 question 10. If you haven't seen question 1 to 9, you can check those out in the link in the description below. So let us go. Question A, part 1 says, given the matrix W, and yes, it is under vectors and matrices, it is equal to 3, 6, negative 2, 5. Determine 1, the 2 by 2 matrix L such that L plus W is equal to 0, 0. Now, for the result to be 0, 0, it really meant that W was being multiplied by basically the negative version of itself. So basically, W itself was multiplied by negative 1, and it is the result from that that would be L, which would allow W plus L being 0, 0. But if you're working it out in the equation format, basically you'll have the 3. So this is W, 3, 6, negative 2, 5, and we don't know what L is, which is what we're trying to find. So we're going to call it A, B, C, and D is being equal to 0, 0, 0, 0. So what we're going to do here is to now basically equate and solve for the unknown. So that's what you're doing when you're adding matrices. So we'll have 3 plus the unknown, which is in the same position, being equal to the result, which is in the same position. So we'll have 3 plus A is equal to 0. So it will be 3 plus A is equal to 0. You'll solve for A, and what you'll get A to be is A is therefore equal to a negative 3. You'll do the same thing for B. So it will be 6 plus B is equal to 0. Solve for B, and therefore B is equal to a negative 6. You'll do the same thing for C, which will be negative 2 plus C is equal to 0. So negative 2 plus C is equal to 0, and therefore C is equal to a positive 2. Same thing for D. 5 plus D is equal to 0, and therefore D is equal to a negative 5. So therefore, those are the coordinates for L, and that is what I was saying to you, that it was basically W being multiplied by a negative 1. So it was 3 times negative 1 to give us negative 3, 6 times negative 1 to give us negative 6, negative 2 times negative 1 to give us a positive 2, and 5 times negative 1 to give us a negative 5. And that's basically what L is. So therefore, L is equal to So therefore, L is equal to negative 3, negative 6, 2, negative 5. And that is the matrix L, which, as I was saying, which is basically the same as if we had done a negative W. Basically, it would have been the same thing, because this is just a 1-mark question. So any way that you choose to work it would be fine. So whether you choose to work it out the long way, or just by saying L would be equal to a negative W, because that's the only way you can get your resulting matrix to be 0, 0, 0, 0. So now on to part 2. It says the 2 by 2 matrix P. So we're determining the 2 by 2 matrix P such that WP is equal to 1, 0, 0, 1. So this is an identity matrix, and the only way that we can get an identity matrix is if one matrix is basically being multiplied by the inverse of itself. So basically what we're doing then is to be W being multiplied by the inverse of itself, which would have gave us this identity matrix. So it is that which would result in this, the identity matrix. So therefore, in order to find the inverse we'll first need to find the determinant of 0. So basically what we're saying is therefore the determinant, well, before we go on, so as you'll see, we have 0 here. We are basically using 0, not 0, W, the inverse, to be equal to P. So that is basically what we are doing here. So therefore, the determinant, to find the determinant, we will be multiplying the first diagonal, so 3 times 5, the 3 times 5, minus the second diagonal, which is 6 times negative 2. So therefore, what we'll have here is 3 times 5, that will give us 15, minus 6 times negative 2, that will give us a negative 12, and therefore what that will give us is 27, because you know this minus times this will result in a positive sign. So 15 plus 12, that will give us 27. So therefore our determinant is 27. So now in order to find the inverse, it is 1 over the determinant, which is 27, being multiplied now by the original matrix. But when you're writing about the original matrix, you're first switching the numbers in the first diagonal. So where there's 3, we'll put 5, and where there's 5, we will put 3. And then the sign on the second diagonal, it basically changes. So if it was positive, it becomes negative, and it was negative, it becomes positive. So therefore, this 6, which was positive, becomes a negative 6, and this 2, which was negative, becomes a positive 2. And now basically that is the inverse, and from here on we're just simplifying. So now we're just multiplying 1 over 27 times each number in the matrix. So it is 1 over 27 times 5, and what we'll get is 5 over 27. And then we have negative 6 multiplied by 27, 1 over 27. So what we have is negative 6. So we have negative 6 being divided by 27. And all right, so go again. So it is negative 6 divided by 27. So if you just have to write that way, something is going on. So negative 6 divided by 27. Okay. And then we have 1 over 27 being multiplied by 2. So what we'll have is 2 over 27. And then we have 1 over 27 multiplied by 3. So what we'll have is 3 over 27. And if anything can be simplified, you go ahead and do so, which in this case, this one, the 3 over 27, can be simplified, this term. So we'll write back everything and simplify that portion. So we'll have 5 over 27 here. Then we have negative 6 over 27 here. For this one, 2 over 27. And then for this 3 over 27 can be simplified. 3 into itself goes 1 time. 3 into 27 goes 9 times. And as we made the statement before, the inverse W is equal to P. So that is what is here. So our final answer, this is the matrix P, which is the same as the inverse of W, because that is the only way we can result in the identity matrix. So this is our final answer. So part B says a right-angled triangle M has vertices 1, 1 for X, 3, 1 for Y, 3, 4 for Z. When M is transformed by the matrix N, which is equal to 0, 1, 1, 0, the image is M prime, and they want us to find the coordinates of the vertices of M prime, which is basically the image. So these are the objects, and we're trying to find what the image is. So we're looking at our transformation matrix, which is 0, 1, 1, 0. So based from how this is situated, it is passing through the line where Y is equal to X, so therefore through the origin. So basically what you're experiencing is just a flip or a reflection through that line. and we have our coordinates for x, which is 1, 1, and for y, 3, 1, and for z, 3, 4. Now, if you remember from theory, basically, when this reflection takes place, what happens is just that the y-axis becomes the x and the x-axis becomes the y. So it's just a flip of the coordinates. So if you know to do it that way, simply by remembering the theory, then that would be good. But this is how we'd work it. So you'll do row times column, then row times column, same thing each, row times column going down. So we have 0 times 1, which would give us 0, 1 times 1 would give us 1, so that is 0 plus 1, which will give us 1 here. Then we have 1 times 1 to give us 1, 0 times 1 is 0, so that is 1 plus 0 again to give us 1, 1. So that is our x prime coordinate. Then we have row times column, so 0 times 3 is 0, 1 times 1 is 1. And then 1 times 3 is 3, 0 times 1 is 1, so therefore our resulting answer here is 3. So if you realize the 1, 1 doesn't really change much of everything, because that is on the line which is acting as a reflection line, or the line which passes through y is equal to x, because both y and x is 1, 1. So at that point, we didn't expect to see a change there. But now going on to the y coordinate, 3, 1, as you can see, as I was mentioning, it's a flip. So our x-axis becomes our y, and our y-axis becomes our x. And that will be the same thing which happens for z, which is 3, 4. So it will become 4, 3. Now looking at it, it is 0 times 3, which is 0, 1 times 4 is 4, so that is 0 plus 4, which will give us 4, and then 1 times 3 is 3, 0 times 4 is 4, so we have 3 plus 0, which will give us 3. And these would be the vertices of m prime, which is x prime, y prime, and z prime. So these are the coordinates of our newly reflected right-angled triangle. So this is our answer. Part C now says the diagram below shows triangle OPQ, in which OP is equal to 3u. So OP is equal to 3u, so 2u here, u. OQ is equal to v, and Q is the midpoint of OR, and M is the midpoint of PQ. And it says L is a point on OP such that OL is equal to 2/3 of OP, which is, as you can see right here, is represented by 2u. So it says write in terms of U and V an expression for LM. So, especially in a time like this when gas price is mad expensive, what we're doing is, imagine this is a route that you need to take to go somewhere. So what we're looking for is the shortest route, because there are many routes that you could have taken. So you could have gone from LP to PM, or you could go LO to OQ to QM, but that route seems rather long. So what we're going to do is the LP to PM. So we're going to say LP plus PM, but we don't know what the reading or the expression for PM would have been. So what we need to do is to first, they told us that M is the midpoint of PQ. So we'll need to find the vectors of PQ and then multiply it by a half, which will get the midpoint. So that's what we're going to first do. We're going to find what PM is. So we're going to find what PM is. So PM would be equal to, sorry, this should be PQ. So we're going to find first what PQ is. So PQ, we are going to do PO plus OQ. So we're going in this direction to find what PQ is. So PO, OP was 3U, so therefore PO would be minus 3U plus OQ, OQ is V. So therefore PM would be a half of PQ. So therefore, PM is equal to, because remember it says that M is a midpoint on PQ, so therefore PM would be a half being multiplied by minus 3u plus b. So this would be the reading for PM. You could work this out and go in more details to give us minus 3u over 2 plus v over 2. Any way that you choose to put this in your formula, it is totally fine. As a matter of fact, let us do that. So if we have PM, it would be equal to minus 3u over 2. So that's when we're working out our bracket plus v over 2. So this would be PM. We can now put this back into our original vector equation here that we're looking at, which is LM. LM is equal to, we said LP. We know what LP is, which is u plus, and we have minus 3u. So we have minus 3u over 2 plus v over 2. Working out right here, we have a plus sign, a minus sign, so that will leave us with a negative sign. There are negative terms, so let me just rewrite that. So u would be, LM is equal to u minus 3u over 2 plus v over 2. And we know that 3 over 2 is the same as basically 1.5. So therefore, if we have 1 minus 1.5, what we're left with is basically LM is equal to, it would be a half u, or u over 2 is the same thing, plus v over 2, which is the same. It could be written as if we have the half on the outside. So therefore, LM is equal to a half u plus v. The same thing. These two last expressions, they are the same. So whether you wrote u over 2 plus v over 2, it is the same thing as a half. So all we did here was to just factorize, taking out the common factor, which is a half, and put it on the outside of our bracket. So we have a half, and what was not common was a u plus v. So that is the expression for LM. By the way, right here, this should be a minus sign here, because remember, this is u minus 3 over 2. So it wouldn't be a positive term, it would be a minus a half right here. So this is, if we factorize, what we'll have is minus half multiplied by minus u plus v. So this minus sign should actually, because remember, the bigger term right here, which was 3 over 2, was negative. So that was carrying the negative sign. So it is 1 minus 1.5. That would have left us with the negative a half here. So when we factorize a half, we'd have a negative u remaining for that term. So that is it for LM. Now we're asked to write an expression for PR. So we're looking for R. Where's R? Okay, so here's R here. So that will mean we're coming from here to here. Now there are two routes. You could either go PO and then OR, or you could go PQ then to QR. Anyone that you choose, your answer would still work out to be the same. You already know what PQ is because you worked it out in part 1. So PQ got minus 3u plus v, or if you go PO then to OR, then your answer would still be the same. So let us go. So if we're looking at PR, I'm going to go PO plus OR. So I'm going to go that route. So if we go, PR is equal to PO. OP was 3u, so therefore PO would be minus 3u plus OR O to Q was V, and Q is the midpoint of OR. So if right here is V, it means that right here, so let me identify it, it means that right here was V as well. Because remember, Q is the midpoint of OR. The question did state it. It says Q is the midpoint of OR. So this is Q, it is the midpoint of OR. And if O to Q is V, it means that the other half is also V. So therefore, plus OR, it will be plus 2V. So therefore, this would be plus 2V. And this would be our answer for PR. So therefore, PR is equal to minus 3U plus 2V. If you went this route of PQ, then to QR, your answer would still be the same. So that would be the expression for PR, minus 3U plus 2V. But as I was saying, if you should have went PQ to QR, we already know what PQ is. You will just add, because remember PQ was PQ minus 3U plus V. So this was PQ minus 3U plus V. So now all you'd have been doing is adding QR to it, and QR is V. So you'd have minus 3U plus V, which should have given you the same minus 3U plus 2V as your final answer. So any route that you take, and you would have arrived at the same answer. So we're now at part 2, and it says prove that the points L, M, and R are collinear. So collinear basically means that they are on the same point. So one straight line can go through them. So it is this, you're proving that they are all on the same point, which basically means that in a sense we'll have two parallel lines. So it would be LM then to MR. So what we're basically going to prove here is that both lines share a common point, which would be M, which means that one is probably just a factor of the other. So that is what we are going to prove here. So let's go. So we're basically first going to find LM, which we don't have to work out because we found LM in the first part of the question. Let's see. LM, we got a half bracket minus U plus V. So this would be a half minus U plus V, or if you wrote it as minus U over 2 plus V, I think that's what we will have. Yes, minus U over 2 plus V over 2. So that is LM. Now what we're going to find is MR. So MR would be equal to, let's say, MQ plus QR. We found what PM was, which would be the same thing as MQ, because remember, M is the midpoint of PQ. So therefore, MR is equal to MQ to be a half. Let's go back. PQ was what? So it was minus 3U over 2 plus V over 2. So basically, this being multiplied by minus 3U plus V. So that is MQ plus QR, which is V. So what we'll have here then is MR is equal to, if we expand our bracket here, we'll have minus 3U over 2 plus v over 2 plus v. It should be plus v. So therefore, this is a half v plus 1v. That will basically give us 3v over 2. So let's go. So what we'll have is MR is equal to, so it is minus 3 over 2 U plus 3 over 2V. So this is the same thing. This is what is being expressed here when you simplify. So let me pull this over. So this is it. Now if you look at this, so comparing LM here, so at LM, if we had expand LM here, what we'll have is basically minus a half U plus a half V. So when you compare these two equations, this one here with this one, all that happened was that MR is equal to 3. So let's factorize and take out 3 here. So what we'll have is 3 being multiplied by a half U plus a half V. So if you expand this bracket, as you can see, this LM here is equal to what is in the bracket here. So basically, MR was just 3 times the amount of LM. So basically, MR is equal to 3 times LM. And that is how we prove that our lines are one, they are parallel, and also that they are collinear. So MR is parallel to LM because MR is a scalar multiple. So this is now what we're writing for answer. So we prove using the equation, and we're just now concluding with our statement. So we can say, therefore, MR is parallel to LM because MR is a scalar multiple of LM. So all that happened is just that MR is 3 times the length of LM. So MR is a scalar multiple of LM. So therefore, point 2, this proves that MR is parallel to LM and they share the common point M. So that is it. You could have even done it, let's say LR. So you could have done LM then to LR, and the common point that they would have shared is L. And it would have been the same. This wouldn't have been the same exact answer in terms of the working out, but you would still get some answer which will show that they are parallel and that LR is just a scale. It will just be something of a scalar multiple of LM. Anyone that you choose and your answer would still be the same. So thank you for joining us, and we will see you in another video.